All right, and so to complete the effective temperature on catalase or enzyme activity specifically, we've had 1A has been in the refrigerator in an ice bath for a little over 15 minutes, and we're going to add the hydrogen peroxide to it. I'm going to go ahead and add it in the ice bath because I can put it in frame. I'll put it in frame. Okay. I'm going to go ahead and add it into the ice bath, I think, directly. And then I'm going to pull it out, and we're going to take a look at that. So here's, again, 1A. Right? I'm going to add, pull it out. Now, what happens here, and damn it, I forgot to start that, but that's all right. What happens here is it's very hard to get this catalase, right, cold enough to actually show much of a difference between this and the 35 degrees Celsius. Now, after 20 seconds, whoops, metric, okay, we see that we're at about 12. So there's a difference between this and 2A, but you notice, again, it reacted very quickly. It really didn't slow down. So this does, it does beg the question, so what effect does cold have? Because you all should know that cold temperatures, right, you can die from hypothermia just as you can die from hyperthermia. Now, hypothermia can take longer, and so the reality is that enzymes aren't denatured or they don't come apart because of cold. In fact, when we use enzymes in labs, we store them at -20 or even lower to prolong, because they will, like all chemicals, they'll degrade over time, and cold temperatures slow down the degradative process and decomposition, etc. So the cold itself is expected to slow down the molecules so that the hydrogen peroxide molecules don't get together with the catalase molecules as quickly. But that really wasn't quite demonstrated, was it? I mean, we always have a little bit of a difficulty with this one in the lab because, and there's a couple different reasons I would offer for you guys. I'm just doing it according to what we always have done as a protocol. But it could have to do with the fact that we have such a small container that it's negligible, the effect of this temperature on it. Clearly, if the catalase had been frozen, that would have, taken it to a point where it's not going to really interact with the hydrogen peroxide as quickly as certainly the one that wasn't frozen. But overall, it just, again, what we're illustrating here is the fact that temperature does influence, the activity of enzymes in general, but that influence is different depending on cold and hot. Now, again, you expose yourself to colder temperatures long enough, well, that's going to create such a change in the rate of the reactions on the wide scale of your body that, yeah, you're going to die. But it does, in fact, have a different influence, and the time in which you to death is going to vary by those circumstances. Okay? So not much of a difference between the cold and the body temperature. Certainly a big difference if you've heated up the catalase. Right? So we'll let it go at that, for you guys to think about this and draw some conclusions. But hopefully you're, again, getting some understanding about the conditions in which enzyme activity is affected. And temperature is definitely a very important predictor or physical factor in determining how fast enzymes can get together. So they need a warm enough, but not too warm that you would denature and alter the shape of the proteins or enzymes themselves. I hope this gives you something to think about, and I'll see you in the next video.